Hello science fans, welcome to an exciting exploration of the world around us. Today, we're diving into a topic that touches each and every one of our lives, every single day. Today, let's talk about something we all make every day. Trash. What scientists call municipal solid waste. It's a polite way of saying all the stuff we throw away. From our homes to our schools, waste is generated constantly. Every snack wrapper, that crinkly reminder of a momentary treat, old gadget box, the packaging that once protected our shiny new tech, or fridge cleanout, those forgotten leftovers that have seen better days, adds to a global mountain of garbage. These mountains are growing taller and wider every day, posing a significant challenge to our planet. Multiply your daily waste by everyone on Earth, consider the billions of people inhabiting our planet, and you get a massive, ever-growing problem. A problem that demands innovative solutions and a shift in how we perceive waste. At the same time, our world is hungry for energy. Our modern lives are powered by electricity to power homes, schools, and hospitals. Energy is the lifeblood of our society, essential for progress and well-being. Traditionally, we've burned fossil fuels for energy, relying on these finite resources for generations, but that releases greenhouse gases and worsens climate change. A consequence we can no longer ignore. So we face two big challenges, a dual crisis that requires our immediate attention. Too much trash, mountains of waste piling up, threatening our environment, and a need for cleaner energy. A sustainable alternative to power our world without harming the planet. But what if our waste could help solve both problems? What if the very thing we discard could become a source of clean energy? Imagine banana peels and cardboard boxes powering your home, turning everyday waste into a valuable resource. This isn't science fiction, it's science fact. Cutting-edge research and innovative technologies are making this a reality. By rethinking waste as a resource, we can unlock its hidden energy, transforming our perception and approach to waste management. Instead of burying trash in landfills for centuries, we can transform it into something useful, giving waste a new purpose and extending its life cycle. This is the heart of the circular economy, a system designed to minimize waste and maximize resource utilization. Reuse, extending the life of products and materials, recycle, transforming waste into new raw materials, regenerate, creating new value from discarded items. It's about closing the loop and seeing garbage as potential, recognizing the inherent value in what we throw away. Let's explore how we can turn our trash into electricity, uncovering the science behind waste-to-energy technologies. The possibilities are electrifying, a future powered by innovation and sustainable practices. Ready to see how science can turn our waste into power? Let's dive in and explore the fascinating world of waste-to-energy. So, what exactly is waste-to-energy, often abbreviated as WTE? It's a concept that's gaining traction as we seek innovative solutions for managing our ever-growing waste streams. At its core, it's the process of generating electricity, providing a valuable power source. Or it can be used to produce heat, which can be utilized for various industrial processes and district heating systems. In some cases, waste-to-energy can even be harnessed to create fuel, offering a sustainable alternative to traditional fossil fuels. Instead of simply letting trash rot and accumulate in landfills, taking up valuable space and posing environmental risks, we use cutting-edge science and innovative technologies to unlock the hidden energy that's trapped inside the waste materials. This includes everything from discarded paper products, right down to the leftover pizza crust from your dinner. Because, believe it or not, almost everything contains stored chemical energy within its molecular structure. Waste-to-energy technologies provide us with the means to safely and efficiently release that energy, transforming what was once considered useless into a valuable resource for us to use. There are several different methods employed in waste-to-energy plants. Some methods rely on high heat to incinerate the waste, while others harness the power of microbes to break down organic matter, and still others utilize complex chemical reactions to convert waste into usable energy. But the ultimate goal remains the same: to turn unwanted waste materials into a much-needed source of energy. This generated energy helps power our electrical grid, providing a reliable source of electricity for homes and businesses. It can also be used to efficiently heat buildings, especially in urban areas with district heating systems. In essence, waste-to-energy offers a dual benefit, tackling two pressing problems at once: waste disposal and energy production. Landfills, by contrast, present a less sustainable approach. They allow organic waste to decompose naturally, which releases methane gas into the atmosphere. a greenhouse gas that's significantly more potent than CO2, contributing to climate change. Waste-to-energy offers a better alternative by diverting waste away from landfills, efficiently capturing valuable energy while simultaneously reducing harmful emissions into the atmosphere. It's a vital component of a comprehensive and sustainable waste management strategy, providing a solution for handling waste materials that simply can't be reduced at the source, effectively reused for other purposes, or efficiently recycled into new products. It's science in action, transforming our waste into a valuable resource, making our world cleaner, more sustainable, and more powerful. The sheer volume of waste we generate as a society can feel overwhelming. But what if we could shift our perspective, viewing this waste not as a burden, but as a valuable resource waiting to be unlocked? Let's break down the 4 main ways we turn trash into energy. These methods are not just about disposal. They're about creating a circular economy where waste becomes a feedstock for new products and energy sources. It's about minimizing our environmental impact and maximizing the value we extract from the materials we use. First, incineration. This is one of the most established and widely used methods for waste-to-energy conversion. We burn trash in high-tech facilities designed with advanced pollution control systems to minimize emissions and protect air quality, using the heat to make steam, spin turbines, and generate electricity. This electricity can then be fed into the grid, providing a reliable source of renewable energy. Second, anaerobic digestion. This process harnesses the power of microorganisms to break down organic matter in a controlled environment. Microbes break down organic waste in oxygen-free tanks, mimicking the natural decomposition process that occurs in wetlands and other anaerobic environments, producing biogas, mostly methane, that we burn for power. This biogas can be used to generate electricity, heat buildings, or even be upgraded to renewable natural gas for use in vehicles. Third, gasification. This is a thermal process that converts waste into a gaseous fuel called syngas. We heat waste with little oxygen, carefully controlling the temperature and pressure to optimize the gasification process, creating syngas, hydrogen and carbon monoxide, a versatile fuel that can be used in a variety of applications, that can be burned for electricity or turned into fuels. Syngas can also be used as a feedstock for the production of chemicals, plastics, and other valuable products. Fourth, pyrolysis. Similar to gasification, pyrolysis is another thermal process that breaks down waste in the absence of oxygen. We heat waste in zero oxygen, preventing combustion and allowing the organic molecules to break down into simpler compounds, producing syngas, bio-oil, and biochar, each with valuable uses. Bio-oil can be used as a fuel or further refined into transportation fuels, while biochar can be used as a soil amendment to improve soil health and sequester carbon. Incineration handles mixed waste and reduces landfill volume, significantly extending the lifespan of existing landfills. Anaerobic digestion is perfect for food scraps and manure, diverting these organic wastes from landfills where they would otherwise decompose and release harmful greenhouse gases, creating energy and fertilizer. The digestate, the solid residue left after anaerobic digestion, is a nutrient-rich fertilizer that can be used to improve crop yields. Gasification and pyrolysis are high-tech, flexible, and can handle a wide range of waste feedstocks, including plastics, tires, and other materials that are difficult to recycle, and can make electricity, fuels, or chemicals. This versatility makes them attractive options for communities looking to diversify their energy sources and reduce their reliance on fossil fuels. Each method has its strengths and its own set of considerations, depending on the type of waste and desired outcome. Careful planning and analysis are essential to selecting the most appropriate technology for a given situation. These technologies are our scientific toolbox, providing us with a range of options for managing waste and generating valuable resources, for turning trash into treasure. By embracing these innovative approaches, we can create a more sustainable and resilient future. The right method depends on the waste and the community's needs, taking into account factors such as waste composition, energy demand, and environmental regulations. Science and engineering make it possible to design and optimize these waste-to-energy systems, ensuring that they are both efficient and environmentally sound, to extract value from what we throw away. This is not just about generating energy, it's also about recovering valuable materials that can be reused or recycled. Instead of seeing garbage as a problem, a source of pollution and environmental degradation, we see it as potential energy, a valuable resource that can be harnessed to power our homes and businesses. These processes are changing how we think about waste, shifting our mindset from disposal to resource recovery. Trash is no longer just trash, it's a resource, a valuable commodity that can be transformed into energy, fuels, and other useful products. Let's see how different places are putting these ideas into action, implementing innovative waste-to-energy solutions to address their unique challenges and opportunities. With 4 main WTE methods, how do we choose the right one? Incineration is great for mixed municipal waste and saves landfill space but requires advanced pollution controls. Anaerobic digestion is ideal for wet organic waste, producing energy and fertilizer, but needs good waste separation. Gasification and pyrolysis are cleaner and more flexible, making electricity, fuels, or chemicals, but work best with uniform pre-processed waste. Each method fits different waste types and goals. Smart choices mean better results for the environment and economy. The future is about matching the right technology to the right trash. Science helps us make those choices. Let's look at who's leading the way. Around the world, countries are proving waste-to-energy works. Sweden leads the way. Less than 1% of its household waste goes to landfill, and its WTE plants provide heat and electricity to millions. Sweden even imports trash from other countries, turning it into energy and profit. Japan, with limited landfill space, has hundreds of advanced incineration plants with strict emission controls and innovative ash recycling. Denmark's Copenhagen plant is so clean it has a ski slope on its roof. These countries show that with smart policies and investment, trash can become a valuable resource. Waste-to-energy is not just a dream, it's a reality. Clean, efficient, and community-friendly plants are possible. The world is learning from these leaders. Waste-to-energy plants are expensive to build, but the investment pays off. Landfills take up space, require decades of monitoring, and release methane, costs that add up over time. WTE plants generate revenue by selling electricity and heat, and sometimes by recovering metals from ash. Some even charge fees to accept trash from other regions. The economic benefits include jobs, local energy, and reduced reliance on fossil fuels. When you add environmental savings, the case for WTE is strong. It turns a costly problem into a valuable asset. Smart cities see WTE as essential infrastructure. The payoff is cleaner air, less landfill, and a stronger economy. Waste-to-energy isn't perfect, there are challenges. Air pollution from incineration is a concern, but modern plants use advanced filters and scrubbers to keep emissions low. Public perception can be a hurdle. People worry about noise and pollution. Transparency, education, and real-time emissions data help build trust. Showcase plants like Copenhagen prove WTE can be clean and community-friendly. Another challenge, WTE must not discourage recycling. The priority is always to reduce, reuse, and recycle first. WTE is for what's left. Countries like Germany and Sweden show high recycling rates, and WTE can work together. With smart policies, WTE is a safe, effective part of waste management. Waste-to-energy is just one way to find value in our trash. Composting turns kitchen and yard waste into rich fertilizer, improving soil and reducing chemical use. Ash from incineration can be processed and used in construction, reducing the need for new materials. High-tech recycling, like chemical recycling, breaks down plastics into their building blocks for reuse. E-waste mining recovers precious metals from old electronics, turning gadgets into gold mines. These innovations show that waste is a resource, not a burden. Science is finding new ways to recover value from every stream. The future is about using everything we throw away. Our trash is full of hidden potential. The future of waste management is exciting and innovative. Plasma gasification uses extreme heat to break down waste, creating clean fuel and safe byproducts. Artificial intelligence is revolutionizing waste sorting, making recycling and WTE more efficient. Integrated systems will combine AI, recycling, composting, and advanced WTE technologies. Cities will become circular. Outputs from one process become inputs for another. Our trash will power our communities and help build a sustainable future. The science is ready. Now we need the will to act. Cleaner, greener cities are within reach. Let's get to work.